Hi, it's Mrs. Moret with help on today's assignment, Unit 4, Lesson 1. For number 1, select all sequences that could be geometric. So remember, geometric sequences are going to have a constant multiplier or a constant factor. So I'll check each one. So to get from 2 to 4, multiply by 2, but then 4 times 2 is 8, not 7, so not A. On B, if I multiply 1/3 by 3, I get 1, and then times 3 is 3 and times 3 is 9. So B is going to be a geometric. On C, 1 times 3 to get to 3, but 3 times 3 is 9, not 5, so not C. On D, to get from 1/2 to 2, I multiply by 4. And so I'm going to check here. So 1/2 times 4 is 2, 2 times 4 is 8, 8 times 4 is 32. So D is geometric. And then in this direction, I'm actually like multiplying by a fraction. So I do know that 1,000 times 1/5 is 200. 1,000 times 1/5 gives me 200. And now if I multiply that by 1/5, I get 40, so that's good. And then I multiply that by 1/5, and I get 8. So that one's a yes. And then on F, I can just see that this is arithmetic because it's continuously adding -100. So B, D, and E are the geometric sequences for number 1. On number 2, it says a blogger had 400 subscribers to her blog in January. So 400 in January. And then the number of subscribers has grown by a factor of 1.5 every month since then. Write a sequence to represent the number of subscribers in the 3 months that followed. So she starts with 400, and then it grows by 1.5 each month. And so for the first month, 400 times 1.5 is 600. I'm going to multiply that by 1.5, and I get 900 for the second month. And then for the third month, I'm just going to multiply by 1.5 again, and we get 1,350. Number 3 is an interesting question. This comes up a lot. Tyler says the sequence 1, 1, 1, and so on of repeating ones is not exponential because it does not change. Do you agree with Tyler? Explain your reasoning. So for a sequence to be exponential, it just has to have a common factor. And it does have a common factor. It's 1. So you could say that you disagree with Tyler. Although the sequence isn't changing, it does have a constant multiplier of 1, so it would then be considered exponential. Number 4, in 2000, an invasive plant species covered 0.2% of an island. For the 5 years that followed, the area covered by the plant tripled every year. So it tripled every year for 5 years, starting with 0.2%. A student said that means that about half the island's area was covered by the year 2005. So we're going to figure out if that's actually true. So originally 0.2%, and 0.2% as a decimal would be 0.002. Okay, so we're going to take that number 0.002 and multiply it by 3 5 times. So 3 to the 5th is how we do that. All right, so put that in here, 0.002 times 3 to the 5th is 0.486. So this is equal to 0.486, which as a percent would be 48.6%, really close to half. So I would agree. I would agree because this is very close to half, and he does clearly say about half the island's area would be covered by that plant in 2005. Okay, moving on. Number 5, a square picture with side length 30 centimeters is scaled by 60% on a photocopier. The copy is then scaled by 60% again. What is the side length of the second copy of the picture? So it starts at 30 centimeters, and then it's scaled by 60%, so 0.60, and it happens twice, so we'll use an exponent of 2. So 30 times 0.60 to the second is 10.8. So 10.8, and these are centimeters. And then number 4, what is the side length of the picture after it has been successfully scaled by 60% 4 times? So 4 times, you could do it 2 ways. You could rewrite this and use an exponent of 4, or you could say, oh, well, this is what happens 2 times, so it needs to go 2 more times. Either way, you should get the same result. So I'm just going to go ahead and use the 30 times 0.60 to the 4th. I'll type that into the calculator. So 30 times 0.60 to the 4th, 3.888. And then just to kind of show you, if I did 10.8 times 0.60 to the second, look at that. We get the exact same answer because this is the answer when it's been done twice. So then 2 more times at 60%. So 3.888. All right, number 6, a geometric sequence G starts 5, 15. Explain how you would calculate the value of the 50th term. All right, so I would definitely want to use an exponent for this because I wouldn't just want to continuously multiply until I get to the 50th term. So if we say, oh, the first term is 5 and the second term is 15, I know I found that by multiplying by 3. So 15 times 3 is 45. So when I think about it, for the first term, I don't multiply by 3 at all. For the second term, I multiply by 3 once. For the third term, I multiply by 3 twice. So for the first term, second term, third term, right? So the 15, that is 5 times 3 to the first. Then I multiply by 3 again to get the 45. So that's 5 times 3 to the second. And so I noticed that the term number is 1 more than the exponent that I have to use. And it happens here as well. The term number is 1 more than the exponent I have to use. So if I want to take this pattern out to the 50th term, then I'm going to need to do 5 times 3, and then my exponent will be 1 less than 50. So 5 times 3 to the 49th is how I would do that. That would give me the 50th term. And finally, number 7. I think the simplest way to answer number 7 is to simply use the calculator. There's lots of other ways we could figure this out. We could use exponent properties as well, but let's just check on a calculator. So first of all, what is 9 to the 4th? It's 6,561. So I'm just going to check. How about 3 to the 6th? Nope. How about 3 to the 8th? I'm going to guess the answer is yes here, and it is. So B, those are the same. So I think about 3 to the 8th versus 9 to the 4th. There was this little exponent property that you learned earlier in the last unit, and this will be equal to 3 to the 4th times 3 to the 4th. And when the exponents are the same, you can multiply the bases. So there's a little proof for that. But the calculator also shows us the equality. This one is obviously going to be a yes, because when two powers have the same base, you add their exponents. That would give us 9 to the 4th. This one would actually be equal to 9 to the 6th, because you subtract the exponents when you are dividing, and 4 minus -2 is equal to 6. And then E is also going to be a yes. We kind of showed that in part B. And then just to verify, I can use my calculator and show you. 3 to the 4th times 3 to the 4th is 6,561. So that is the end of your homework help, and I hope it was helpful for you.